First of all, I want to welcome you all. I'm Host-Jablonski. I'm an architect. I work at Design Coalition. Today I'm a homeowner as well, and I'm welcoming you to my home.
30 Lansing Street in Madison, Wisconsin is being constructed as a research and demonstration project with the goal of integrating green building practices into a conventional urban setting. The wood-efficient structural system is modeled on the National Association of Home Builders' Optimum Valued Engineered Framing.
The structure is a very simple 2x6 structure, 24-inch on center studs.
The structural loads, floor joists, and roof trusses all bear directly over the wall studs.
Up there.
One minor alteration is letting in one of the top plates. It gains us some extra insulation value and functions as a window header too.
You put the windows between the studs and you use this as a header, you get a very simple framing system. It's very quick. You use quite a bit less wood.
By sizing the windows to install between the studs, we avoid large old-growth headers and all the extra framing around the openings. This home used about 1/3 less wood than if it were conventionally framed. Straw clay walls are the heart of this integrated building system.
The art of straw clay, as we're discovering, is to put as little clay in it as possible. It's to make it the highest percentage of straw. The clay has some real advantages in terms of moisture, in terms of cohesiveness of the wall and so on. So in this climate where you want a thick, well-insulating wall, you use as little clay as you can get away with.
It's nice and coated. All the straws are nice and brown. So you just bring out a bunch like this and you twist it a little bit and you wad it together. And if it keeps its form.
Earth and straw mixed have been used as a building material for millennia. There are 400 to 800-year-old straw clay structures in Germany and Japan that are still in service today. Straw clay is a non-load-bearing infill material. Properly mixed and detailed, straw clay with natural plasters is a durable, energy-efficient, mold and mildew-resistant, low-impact, and non-toxic wall system.
We're using this clay from this place in Wisconsin for our base layers. For our final coats, where we need finer control, we do have the dry bag clay.
This project has afforded us the opportunity to master the art and advance the science of earth-based plastering. Our plasters are mixes of sand, clays, lime putty, and chopped straw fibers.
So we'll add that last. We'll add this
Small
last.
quantities of added casein, which is a milk protein, and linseed oil significantly improve weathering and moisture penetration properties. Our recipes vary for scratch coat, brown coat, or finish coat, and whether for interior or exterior. Roof overhangs are extremely important for the longevity of the home. Generous overhangs protect walls and windows from sun and rain and can greatly reduce maintenance and water problems. And carefully sized overhangs on the south-facing walls allow solar heat to reach the window in winter, but shade them in the summer. They are an integral part of the home's passive solar heating and natural cooling systems. A Midwestern home can save a significant percentage of its heating bill by using the sun's energy. Passive solar design is a cost-effective way to do this. A passive solar house needs 3 things. First, a good high-performance thermal envelope, its walls, windows, and doors, and good roof insulation. Second, the correct size of windows and house orientation to the sun. And third, thermal mass for storing heat. The thermal mass of this house is in the floor. The slab, soil cement in our case, is supported by rows of bricks or concrete blocks. The design is called an air core floor because room air, heated by the sun, circulates under the slab. Here's how the passive solar cycle works. The sun enters the south-facing windows, heating the floor and air. A blower circulates warmed air under the slab to store the heat. At night, the insulating shutters are closed and the stored heat rises into the room. In summer, the cycle is reversed to keep the house cool naturally. Sun and heat are excluded with overhangs and shutters. Cool night air flushes out the house, and the thermal mass stores the cool for the next day.
So you want to vary the exposure a little bit as you go.
These shingles are 100% recycled, half ground up wood pellets and half waste plastics. They include UV stabilizers and come with a 50-year warranty. In the exterior walls, the electrical wiring is conventional non-metallic sheathed type UF. It's stapled tight to the framing to avoid damage when the walls are packed with straw clay. Scrap plywood extenders bring the boxes to the interior. To help minimize exposure to stray voltage and electromagnetic fields, we use flexible MC-type wiring for circuits within 6 feet of sleeping areas. The interior doors and many other elements in the house are reused or recycled. But the windows are new because the performance of the windows is crucial to overall energy conservation. The north-facing units are triple glazed, and all the windows include low emissivity coatings.
This is the heat for the entire house, plus the heat for the hot water, all in this little unit. It's the size of a suitcase.
This quiet side boiler burns natural gas at 90% efficiency, similar to the most efficient furnaces, and much better than conventional water heaters. The onboard computer gives priority to domestic hot water heating over space heating. This is one of the few heating units available that will operate efficiently at the very low heat loss rates that are typical of small, well-insulated homes. Heat is delivered to different zones in the house via radiant ceiling tubes, refurbished cast iron baseboards, and through tubes embedded in the slab floor. Winters in Wisconsin are cold, and if you're going to build a home warm and free of drafts, you must build a very tight envelope. Yet, good ventilation is needed to prevent the indoor air from becoming stale and unhealthy. The answer is an energy recovery ventilator, an ERV. These simple units consist of a box with 2 fans and a special core element inside. This RenewAir unit is made in Wisconsin. The ERV uses the stale, outgoing warm air to heat the incoming cold, fresh air. The 2 air streams pass through the core, exchanging heat, but never actually mixing. Controls are programmable. Small ducts draw stale air from bathrooms and the kitchen. This house incorporates many products that are recycled, reused, and low toxin. Sustainably harvested black locust for decking, white oak for flooring, and aspen for walls. Reused kitchen cabinets, sealed to prevent off-gassing of formaldehyde. Surplus tiles in the kitchen and the bathroom. Ultra-low toxin paints and adhesives, paint made from milk, second-hand light fixtures. Insulation made from recycled newspapers and blue jeans. Even the original front sidewalk was saved and reused. Sizing a house just right means designing for livability as well as affordability and efficient use of natural resources. The house dimensions are 24 by 36 feet, a compact 864 square footprint. The second floor is somewhat smaller because the walls are actually the sloping roof trusses. It will have cabinets and closets built into the areas with sloped ceilings. This is the 2-bedroom version of this house, with 1,114 square feet total, a bath and a half, and an open ceiling over the main living and dining areas. We're using south-facing skylights as solar heat collectors. These will have insulating shutters and a summertime venting system built in. Another innovation is the roof venting and channel system. This system gets rid of wintertime moisture like normal venting. It also vents summer heat. In addition, The channels form an inexpensive, faux cold roof feature. This design eliminates problems of roof leaking due to the ice damming that's common in the upper Midwest. Sheets of house wrap material are stapled into channels between the roof trusses. House wrap lets water vapor pass through, permitting the insulation to stay dry. But house wrap sheds liquid water, so if the roof ever leaks through the shingles, water will drain harmlessly to the outside. We've found a way to build straw clay walls that are simultaneously strong and cohesive and lightweight and well insulating. Roughly 15 to 20% of winter heat loss of an average house is through the exterior walls. For homes in the upper U.S. and Canada, a wall's insulating level, called R value, should be at least 20. We recently worked with the Forest Products Laboratory in Madison to conduct the first thermal performance tests of straw clay in the U.S. The Forest Products Laboratory tests confirmed that our 12-inch thick straw clay walls achieved an R value of 21.
The art of earthen plastering on a straw clay wall is tuning the permeance of the inside wall and the permeance of the outside wall such that there's less resistance on the outside, so it's not as dry to the outside. And there's a lot
Moisture in a house, and with it mold and mildew problems, is another major concern in residential construction. Modern hollow walls have plastic vapor barriers inside and impervious exterior sheathing. When moisture gets inside, it can't get out. A solid straw clay wall works in a different way. Clay is the mechanism that allows the wall to transport moisture, to dry itself from the inside out naturally. We are currently logging daily indoor and outdoor humidity and temperature to quantify this beneficial effect.
This is what the surface is like of a certain formulation. Permeance testing.
We are also carrying on research into the moisture permeance and other characteristics of earth-based plasters. This is not the only way to build, but it is a low-impact way that is durable, energy-efficient, healthy, and naturally mold and mildew resistant. Straw clay is ideally suited to the Midwestern climate, meets building code standards, and combines the best of conventional construction techniques with modern alternative materials and design.